Question number 6. See the question. Test the hypothesis that the attributes A and B are independent using the following table. So this is the test for independence. So obviously we have to use chi-square test. So we know that what to do in this chi-square test of independence. First step, null hypothesis. Here we have to test attributes A and B are independent or not. Attributes A and B are independent. That is our null hypothesis. H1, they are not independent, means they are dependent, but no need to write that thing. Here we have to write under H0. First of all, we have to prepare observed and expected frequency. So observed frequencies are given, and on the basis of that we have to find out expected frequency. So here A not A, B not B, A not A total, B not B total. This data is already given. Values are 1696, 1696. The total of that is 7. Here total is 15. So total is 22. Here total is 10, and here total is 12. Now we know that how to find out expected frequency. So first of all we have to prepare same type of table. A not A total, B not B total, now how to calculate this? Any of you, how to calculate this? Tell me how to calculate this. How to calculate expected frequency?
7 into 10 divided by 22.
7 into 10 divided by 22. That is the way to find out expected frequency. That means 70. 70 divided by 22. So we get 3.18. So here we get 3.18. This total 7 remains same. So now with the help of this only one expected frequency, we are able to find out remaining all. 7 minus 3.18. So we get 7 minus 3.18. So 3.82. Now 10 minus 3.18. 6.82. 12 minus 3.18. 8.82. Sorry, 8.18. So if we add this, you will get 12. If we add this, we get 15. So on the basis of only one expected frequency, we get this thing. Now we have to prepare table observed frequency, expected frequency. But listen carefully. In 2 by 2 table, in 2 by 2 contingency table, if any expected frequency is less than 5, then we have to use Yates correction. The reason is chi-square is a continuous distribution and its continuity remains continuous or remains continue if all the expected frequencies are more than 5. So if any expected frequency is less than 5, in that case the characteristics of continuity is not remains continuous, means it's break. So we have to merge the data, we have to pull the data. But what will happen in 2 by 2 table? Our degree of freedom is 1. In 2 by 2 table, degree of freedom is 1. And once we merge the data, for each additional merging, we lose 1 degree of freedom. So in that case, here we get degree of freedom 0. So it is not possible to obtain the value of chi-square tabulated for 0 degree of freedom. That is why we require this correction, Yates correction. So what we require to do, if any of the expected frequency, here see there are two expected frequency which is less than 5. If only one expected frequency is less than 5, we have to use Yates correction. What we have to do in Yates correction? So you have to calculate, let us consider this is A, B, C, D, observed frequencies. Consider as A, B, C, D. So you have to multiply this 1 with 6, means if there is a observed frequency like ABCD, you have to calculate AD minus BC. If AD, sorry, or AD minus BC or AD and BC, calculate AD and BC and see the relation. Or you have to calculate like this, AD minus BC. If it is less than 0, means if it is negative, AD minus BC, or AD less than BC. If AD less than BC, then add zero point 0.5 in A and D and subtract 0.5 from A and D and subtract 0.5 from B and C, sorry, not A and D, B and C. If AD greater than BC, that is AD minus BC greater than 0, then we have to add zero point 0.5 in B and C and we have to subtract 0.5 from A and D. So this process is known as Yates correction. Yates correction. So Yates correction, that means you have to add zero point 0.5 in 2 observed frequency and you have to subtract zero point 0.5 into observed frequency in such a way that your total remains same. So if we add zero point 0.5 and if we subtract zero point 0.5, see, if we add here zero point 0.5 and if we subtract zero point 0.5 here, so in these two we have to add zero point 0.5 and in these two we have to subtract 0.5. So our expected frequency becomes, sorry, observed frequency. In observed frequency we have to do this thing. So considering this as observed frequency. So now my observed frequency will change. Instead of 1696, now my observed frequency according to its correction, new observed frequency is, so A not A total, B not B total. Your total remains same, but you have to add 0 0.5 in A and D. So according to our data, here we have to add, see, 1 into 6, 1 into 6, that is 6, and 9 6 are, that is 54. So 6 minus 54, which is less than, so here which is negative. So here AD, here 1 into 6 less than, 1 into 6 is less than 9 into 6. Therefore, add 0 0.5 in A and D and subtract 0 0.5 in from B and C. So here we have to add 0 0.5. So instead of 1, we get 1.5. Here we get 6.5. So 1.5, 6.5. And from this we have to subtract 0.5. So we get 5.5, and instead of 12 we get now, sorry, instead of 9 we get 8.5. But see, if our total remains same, 10, 12, 22, here total is 7 and here 15. So there is little change in our observed frequency, and expected frequency, the calculation remains same, 7 into 10 divided by 22. So there is no change in that. Now you have to prepare okay. Now prepare a table, observed frequency, expected frequency, and OY minus EI the whole square upon EI. So observed frequencies are 1.5, 5.5, 8.5, and 6.5. And our expected frequencies are here. Our expected frequency 3.18. If you check, you will see the total here expected frequencies. This 3.18, 3.82, 6.82, 8.18. So 3.18, 3.82. Then 6. Okay, you can calculate 15 into 10, or you can write here 6.82 and here 6.18. Sorry, 8.18. Let us verify once again the corresponding frequency of 8.5. Yeah, it is 6.82. Okay, now calculate this OI minus EI the whole square upon EI. How to calculate? OI means 1.5 minus 3.18 into 1.68 divided by 3.18, but sign should be positive. So 0.89. Now 5.5 minus 3.82, we get 1.68 into 1.68, so it's square, divide by 3.82, so divide by EI, so 0.74. Now 8.5 minus 6.82, 1.68 into 1.68 divided by 6.82, so we get 0.41. And last 6.5 minus 8.18 into 1.68 divided by 8.18, so we get 0.35. Let us add this all values, 0.89 plus 0.74 plus 0.41 plus 0.35, so we get 2.39. So 2.39, that is the value of chi-square cal. So chi-square cal is 2.39. Now next steps are, remaining steps are same. Here chi-square cal summation I equal to 1 to n OI minus EI the whole square upon EI. So 2.39. Degree of freedom, the formula is R minus 1 C minus 1, 2 minus 1 2 minus 1, so it is 1. So degree of freedom is 1. So this is the end of step 2. Step 3, alpha 5%. Step 4, at alpha 5%, and degree of freedom 1, the value of chi-square tab is 3.84. Just check it. So for alpha 5% 0.05 and degree of freedom 1, the value is 3.84. Now last step, decision. Better to draw the chi-square curve like this. 3.84 is the tabulated value. So this is the rejection area and our calculated value is 2.39. So it should be here 2.39. That is H naught is accepted. Better is not rejected. That is H naught is accepted. That is A and B are independent. A and B are independent. That is our conclusion. So this is the way to check the independence when any of the expected frequency, when any of the expected frequency is less than 5. So this is the end of this test. Now let us start next test, test 3 of chi-square, which is very simple, very small test. It is the test of variance of the population. So third use of chi-square, test 3 of chi-square, test of variance for one sample. Test 3, test of variance. It's not test of mean, test of variance. If it is a question for test of mean, then we have to use t-test. This is the test of variance for one sample. So here we have to use chi-square if you want to check the variance of population. What is step 1? H naught. Here you have to write H naught mu equal to mu 0. Instead of that, you have to write sigma equal to sigma 0. Or you can write sigma square equal to sigma 0 square. This is variance, this is standard deviation. Sometimes it is also known as test of standard deviation or variance. It's almost same. So H naught sigma equal to sigma 0 or sigma square equal to sigma 0 square. That is our null hypothesis. In alternative hypothesis, you have to write not equal to, greater than, less than. It's depends on the given question. Okay, step 2. Under H naught, chi-square cal. There is a simple formula, n s square upon sigma square. This is the formula. Or you can write sigma xi minus x bar the whole square upon sigma square. Why? See, we know the formula of s, root sigma xi minus x bar the whole square upon n. Now if we take square on both the side, we get x square and root will cancel. So we get only this thing. And taking n in this side, n s square is nothing but sigma xi minus x bar the whole square. So this is the formula of chi-square cal in our test 3. Here degree of freedom is n minus 1 and remaining 3 steps are same. So here instead of null hypothesis mu equal to mu 0, you have to write sigma equal to sigma 0. So this is our null hypothesis, sigma equal to sigma 0 or sigma square equal to sigma 0 square. Chi-square cal, very simple formula, n s square upon sigma square or sigma x minus x bar the whole square upon sigma square. Degree of freedom is n minus 1 and remaining 3 steps are same like as the previous test. So let us do the exercise. Very simple and short uh, third use of this chi-square. Let us do the exercise. Very few examples are there in our exercise. The question number 2. We have to given that weights in kg of 10 students are given below. This is the weights of 10 students. Can we say that variance of the distribution of weights of all the students from which the above sample of 10 students was drawn is equal to 20 square kg? So we have to check whether the variance is 20 square kg or not for the population. So instead of this word variance, if it is a question of mean, then instead of chi-square, you have to use t-test. So same type of example is there in our t-test, but that was for the mean and this is for the variance. Once again, we have a information regarding 10 students having their weights. So first students have weight 38, second is this and this, like that. Now on the basis of this sample, can we conclude that the variance, not mean, variance in the population is 20 square kg? That is the question. So let us find out the answer of this question. Question number 2. Better to find out first of all here S. So for that what we require to do here, n equal to 10, find out sigma xi and then sigma xi square. Do this calculation. Sigma xi means total of this and sigma xi square. So 38 plus 40 plus 45 plus 53 plus 47 plus 43 plus 55 plus 48 plus 52 plus 49. So 470, that is total of xi. Now take square and add. Do the calculation. Roll number 125. Do the calculation. Be fast. Sigma xi square. Take square of each number and add. Any one of you. Do the calculation. Take square.
22370.
2370.
22370. Double two.
Double two. 22370. Now remaining calculation we know that. No need to calculate sigma x bar in this particular test. We require only standard deviation. So there is a formula of standard deviation, root sigma xi square upon n minus sigma xi upon n the whole square. So if we take square on both the side, so there are different formulas to calculate standard deviation or variance. This is one of the formula. Now calculate. So it is 22370 upon 10 minus this sigma xi upon n is nothing but 47 square. So s square equal to 2237 minus 47 square 2209. So do the calculation. So we get s square equal to 28. Sorry, 18. Oh, sorry, 28. So 2237 minus 2209, that is 27. That is s square. And sigma square, our question is about 20 kg square kg. It's same thing because it is numbers are in sorry, the unit of measurement is in kg and this is variance. So our unit of measurement is 20 kg square, like centimeter square. If you want to find out area, then we have to use centimeter square or meter square or kilometer square, like that. Okay. Now step 1. H naught sigma square equal to 20 and H1 sigma square is not equal to 20. Step 2, under H naught chi square cal. Here the formula is n s square upon sigma square. Our n is 10, s square is 28 upon 20. So we get 14. So chi square cal is 14. Chi square cal is 14. After that, degree of freedom. Here degree of freedom is n minus 1. 10 minus 1, 9. Step 2 over. Step 3, alpha 5%. Step 4, chi-square tab for 5% level of significance and degree of freedom 9. Chi-square tab from the table for 9 degree of freedom and level of significance 5. The value is 16.92. Degree of freedom 9 and 5% 16.92. So it is 16.92 and our chi-square cal is 40. So last step, decision, draw the diagram. Here chi-square cal, sorry tab 16.92. This is the rejection area and our chi-square cal is 14. So chi-square cal is less than chi-square tab. Therefore, H0 is not rejected or accepted. That is, H0 is accepted. That is, sigma square equal to 20 is accepted. So this is the way to find out the answer for this type of question. So question number 3, 4, 5. These are the only 3 questions of this exercise. So consider that as your homework. Very simple. In this already this is given. Sigma xi minus x bar the whole square is given 240. So let us find out s square. How to find out s square? Or you can write direct chi square cal. What is the formula of chi square cal? Sigma xi minus x bar the whole square, that is 240 upon sigma square. Sigma square is what? 25. Only this thing you require to do. 240 divided by 25, you will get 9.6 over. So it's very easy to calculate when this type of information is given. Even in this question number 5, sample size is 10, mean and standard deviation for sample is 5 and 6, and test the population standard deviation. That is the important thing. See, instead of population standard deviation, if it is population mean, then we have to use t-test. Here population standard deviation is 8. So sigma square, this is sigma 8. So here in denominator we get 8 square. What is our formula? N s square upon sigma square. So n is what? 10. S is what? Standard deviation for a sample is 6. 5 is the mean. This is 6. 6 square is what? 36. So 36 into 10 divided by 64. So 360 divided by 64. That is our final answer, 5.625. See, this is the answer, 5.625. So it's very easy to calculate. Here in third question, data is given. So you have to find out first of all s square, and population variance is given. Sigma square is 4. And we know the how to calculate chi square, n s square upon sigma square. That is the formula. So it's very easy to find out the answer of this type of question. So that is your homework, and that this is the end of chi square. In from next lecture we will start new topic, that is app test and analysis of variance. So this is enough for today. If you have any question, you can ask your doubt.